type uses the energy from the sun and converts it into electricity using a solar cell. And second one is solar thermal systems. Solar thermal power plants utilize energy from the sun to heat a fluid to a high temperature. This fluid then transfers its heat to water, which then becomes superheated steam. The pressure from the steam causes the turbine to turn. So, yung first one po is yung photovoltaic power plant. Ito po yung gumagamit ng energy from sun, tapos ikino-convert po sa electricity gamit po yung ating solar cell. So, yung second one po is yung solar thermal system. Ito po yung nag-utilize po siya ng energy galing sa sun, tapos i-heat po nun yung fluid sa pinakamataas temperature, tapos yung fluid po na yon, yung heat ay matatransfer sa water na tapos nagsusuperheat po siya. Yung steam po nun is nagkakos po nung energy para po mag-turn siya into energy. So, next one po is largest photovoltaic power station. Yung una po is yung Badla Solar Park. Ang country po niya is in India and yung capacity po niya is 2,245 and ito po yung kanyang hectares, 5,700. Ginawa po siya ng taong 2020. And next po is yung Huanghe Hydropower Gomod Solar Park. Matatagpuan po siya sa China and 2,200 po ang kanyang capacity. Wala pa po siyang specific na kung gaano po kalaki yung hectares niya eh. And ginawa din po siya ng year 2020. And the third one po is Pavagada Solar Park. Sa India din po siya matatagpuan. Ang capacity po niya is 2,050. And ang land size po is 5,300. And nagawa po siya noong year 2019. And yung fourth po is Benban Solar Park. Matatagpuan po siya sa Egypt. Ang capacity po niya is 1,650 and ang land size is 3,700 and ginawa po siya ng year 2019. And last one po is yung Tengger Desert Solar Park. Makikita po siya sa China. Ang capacity po niya is 1,547. Ang land size po is 4,300 hectares and ginawa po siya ng year 2016. So, eto po sila. Ito po yung Badla Solar Park. Yun po yung sa India. Tapos ito po yung Pavagada Solar Park and yung Huanghe tsaka yung Benban Solar Park. Badla Solar Park in India. The park has a total capacity of 2,245 watts, consisting of more than 10 million solar panels. India's Badla Solar Park is the largest solar power park in the world. Badla Solar Park is located in Badla, a dry and sandy region in Rajasthan, and spans 5,700 hectares with an estimated investment rising to 100 euro billion or 1.3 US dollar billion din po siya. So, solar power plant in Philippines. The Calatagan Solar Farm is a 63.3 watt solar power plant in Calatagan, Batangas, owned by a Solar Philippines. It was reported that the groundbreaking for the solar facility was done as early March 2015. Solar Philippines, a local company, developed the project which cost 5.7 billion. The facility was built by 2,500 people in a 160 hectares or 400 acres land near the foot of Mount San Pedro. Upon its completion, the solar farm has 200,000 panels. Majority of the funds for the project cost was shouldered by the Philippine Business Bank or Banco de Oro, China Bank, and Bank of Commerce also provided funds. By the end of February, the Calatagan Solar Farm is already generating power weeks before the deadline set by the Department of Energy of March 15, 2016. So, ito pong Calatagan Solar farm, kung i-compare po natin siya dito sa mga largest photovoltaic power stations, walang-wala po siya. Ang laki po ng difference natin ng Pilipinas. So, yun po. Next po is, how do solar cells like? So, ito po, yung itsura ng solar cell. Ito po siya yung per piece po dito. Ito po yun. Tapos ito po, yung usually na nakikita po natin sa mga bubong ng bahay or malls. So, how do solar cells looks like? To answer this question, let us first study the components of solar cell. How solar panels mode. So, ito po, ang unang layer niya po ay yung glass. Tapos yung encapsulant and crystalline cells and encapsulant po ulit. Tapos yung backsheet, junction box, and yung frame. So, ito po yung content ng ating isang solar cell. How do solar cell work? Let us start on first thing that is happening inside a solar cell when sunlight strikes it. For maximum efficiency to occur, the solar panel must absorb as many energy as it can from the sun. The more energy it absorbs, the more energy it can supply. So, sa unang-una po ang nangyari po dito, yung sa solar cell po, kailangan po muna niya ng sunlight para po makakuha po tayo ng energy para po, yun po yung umiikot. Yun po yung nagpapaikot para magkaroon po tayo ng energy na nanggagaling nga po sa sunlight. Here is the thing. Somewhere around 5% of energy from the sun is already lost due to reflection once it hit the glass, which is the top layer. To avoid further losses of sun's energy upon entering glass, this is where the anti-reflecting coating comes into play. So, meron po kasing glass na nagre-reflect po yung sun. So, meron din po na glass na para po mas ma-absorb po ng solar cell natin. Yun po yung para po mas nagdadirect po siya sa solar cell natin para po hindi po nasasayang yung sunlight na nagba-bounce back lang ulit. So, next po is scenario to be avoided to prevent losses due to reflection. This happens when coating is incorrect. With the right amount of coating, the reflected energy can be minimized if not totally cancelled. So, yun nga po yung sinasabi ko. Meron nga din pong glass na nagba-bounce back lang po yung sunlight instead po na pumasok po siya sa ating solar cell. So, meron pong right amount of coating po or layer yung ating solar cell. Maybe some of you will ask, what if it just let the light strike the silicon junction without any more barriers on? So, ito nga po yung anti-reflection coating. Let the light in, but mostly it doesn't let the light to be reflected out. It also makes some of the reflected light to get back. Certain manipulation is being done during manufacturing to achieve the characteristics. The silicon, being a semiconductor, is a bit shiny. Exposing directly to sunlight may lose about 30% of the sun's energy to reflection. So, yun nga po. Kaya nga po kailangan po yung mga ginagamit po natin na reflector para po ma-absorb yung sunlight. May right amount po siya kasi po mas nasasayang lang po yung sunlight na nakukuha natin para po magkaroon tayo ng mas maraming energy. Nagre-reflect lang po siya or nagba-bounce back lang po siya ulit. Now, here's the question. What's the main thing that is happening inside a solar cell or photovoltaic cell that is why it is able to produce electricity when the sunlight strikes it? Let us define what photovoltaic effect is. The photovoltaic effect is the generation of voltage and electric current in a material upon exposure to light. It is a physical and chemical phenomenon. To achieve the photovoltaic effect, we need a material which, when struck by sunlight, will exhibit characteristics of a conductor. what is happening inside a copper conductor when there is no present voltage across it? So ang answer po is its valence electron is free to move, transferring from one atom to another in random.
There are number of electrons that moves free. Kumbaga, ito yung process in which two dissimilar materials in close contact produce an electrical voltage when struck by light or other radiant energy. So, dun na pumapasok yung silicon semiconductor which absorb energy from the sun. Yung proton of the sunlight could knock an electron out of its orbit with an atom, making it free to within the system in random. Yung picture or structure sa baba ay silicon crystal lattice, which a diamond cubic crystal, structure in a repeating pattern of 8 atoms. So here's the question. Here's now another question, sorry. What substance should be used as dopant for the silicon to become negatively charged? What substance should be used as dopant for the silicon to become positively charged? When silicon be doped with more valence electrons, it creates a negatively charged, while is doped with less valence electrons, it creates a positively charged. As you can see, this is the example of representation of the topic that we are discussing. On the N-type side, phosphorus is being used as the doping materials, while on the P side, the boron is one being used. Okay, another question now is, why phosphorus is the one being used as dopant to create N-type side and boron to create the P-type sides? Let's find out. Since there is rush of electron from the N side towards the P side, the charge of the two sides will be reversed, making the boron doped P side becomes slightly negative and phosphorus doped N side is slightly positive. The majority carries in a P-type semiconductor are holes. In an N-type semiconductor, pentavalent impurity from the B group is added to the pure semiconductor. Depletion region, which the rush electron will quickly from a barrier between the two sides. Here the equilibrium is also being reached as the electron stops flowing and the electric field will definitely created. This picture represents how the depletion region occurring. In the P-type region, there are holes from the acceptor impurities, and in the N-type region there are extra electrons. When a P-N junction is formed, some of the electrons from the N region which have reached the conduction band are free to diffuse across the junction and combine with the holes. Step-up transformers are required to boost the 480 to 690 voltage inverter's output voltage to the 13.8 voltage to 46 voltage of the medium voltage utility network. It is then connected to a substation for distribution into residential area. Each panel produces a relatively small amount of energy, but can be linked together with other panels to produce higher amount of energy as a solar array. In this picture, represent how PV power plant work. Next, solar thermal power plants collects energy from the sun with the use of mirror, and this collected energy reflected or redirected in a tube where a heat transfer fluid is heated and circulated in the receiver and used to produce steam. The steam is converted into mechanical energy in a turbine, which powers a generator to produce electricity. There are different types of solar thermal system. First, parabolic through. Second, solar power. Third, linear Fresnel reflector. And the fourth is a parabolic dish. Next, in this picture, You can see how the different types of solar thermal system work and its structure. But as you can see, they are same in principle that they collecting energy from the sun. Even they are different types. So let's find out what's the difference in these types of solar thermal system. First is parabolic dish. These struts, also known as the line focus collectors, are lined up in a now on a solar field and are composed of a long parabolic shaped reflector that concentrates incident sunlight on a pipe that runs down at the middle of the true. So it's designed to capture the sun's direct solar radiation over a large surface area and focus or more generally concentrate it onto a small focal point area, increasing the solar energy received by more than a factor of 2, which means more.
Good day everyone, my name is Yuan Origi Diaz from BSc E3D. Ang topic ko na discuss ko ngayon is parabolic flows operating principle. First, heat from the sun is being collected by special mirrors, which is then reflected to the pipe that runs down the middle of the trough. Second, within this central pipe is a heat transfer fluid or HTF flowing inside it. The HT The HTF inside the pipe can reach a temperature around 400 degrees Celsius, as the probe focuses sun at 30 to 100 times its normally intensity. This hot fluid goes to heat exchangers, where the heat is transferred to water, generating high pressure superheated steam. Of this steam then moves a turbine to power a generator and produce electricity. The HTF then keeps circulating within the system. The steam is being condensed, which is to be sent back heat exchangers. Sa loob daw po ng gitnang tubo na ito ay may heat transfer fluid na dumadaloy po sa loob nito. Ang HTF sa loob ng pipe ay maaaring umabot sa temperature around 400 degrees Celsius. Then, the tube focuses sun at 30 to 100 pesos sa normal na intensity nito. Heat transfer fluids, general description. In a solar thermal system, heat transfer fluid or HTF is a liquid or a gas specially manufactured for the purpose of transmitting heat from one system to another. Sa isang solar thermal system, ang heat transfer fluid or HTF ay isang liquid o isang gas na particular na ginawa para sa layunin ng pagpapadala ng init mula sa isang system patungo sa isa pa. Why use heat? Why use HTF instead of the direct system in which water is instantly turned into steam by the heat reflected by mirrors in solar thermal system or CSP? The answer is these working fluids have high heat capacity. It can maintain a or high level of hotness in a long period of time. That is why in CSP, large volume of HTF is heated to an elevated temp during daytime, where sunlight intensity is at its peak. Then it is being stored in a tight vessel. It acts as a reserve power that can be used during cloudy days when the sun's intensity is at its lowest or during nighttime where there is totally no presence of sunlight. Heat transfer fluid. The heat transfer fluid used in CSP technologies includes air water, molten salts, glycol-based glycerol based on synthetic oils. Heat transfer fluid. The following characteristics are being considered on what type of HTF is to be used in a solar thermal power plant. First, operating temperature. Second, life cycle. Heat transfer capacity. Heat storage aspect. Overall safety. Cost. Note, the use of molten salt in parabolic flow system can heat the heat transfer fluid (HTF) to 550 degrees Celsius has a better performance than a synthetic oil, which can heat the HTF to only 400 degrees Celsius or less. Solar tower working principle. The setup includes an array of large number computer controlled sun tracking mirrors known as heliostats. Sunlight can be concentrated as much as 1,500 times its normal intensity. This mirror moves in dual axis and are located at the ground level, which collects energy from the sun, then reflects it towards a receiver which contains HTF located at the top of a tower. The HTF is being heated at around 600 degrees Celsius. And just like in the parabolic through this HTF, through pipes, it goes to a set of heat exchangers. Then it transfers heat to the water turbine generating high pressure superheated steam which is being used to turn a steam turbine. Fresnel reflector. The design of this type is the combination of parabolic through and solar tower. These use flat mirrors instead of parabolic mirrors used in a parabolic throw. These flat mirrors moves in one axis only, unlike solar tower and parabolic dish, which moves in two. It adapts the working of solar tower, where the on the ground collects lights from the sun and reflects it towards a fixed receiver located above. Ang design na ganitong uri daw po ay ang combination ng parabolic throw and the solar tower. Gumagamit ito ng mga flat mirror sa halip na ang parabolic mirror na ginagamit sa parabolic throw. Linear Fresnel reflector. Previous designs generates steam directly without the use of HTF, which are now obsolete. LFR nowadays also uses HIF to generate steam. The classic the classic LFR has only one linear receiver on a single linear tower to increase optical and ground use efficiency. The improved design called compact linear Fresnel reflectors or CLFRs use multiple receivers for each set of mirrors so that adjustment mirror have different inclinations in order to target different receivers. The previous design generates steam directly without the use of HTF na ngayon ay hindi na ginagamit. Ang LFR ngayon ay gumagamit din ng HIF to generate steam. Flat mirror are used which are cheaper. One big disadvantage with this design is the shading effect of adjust, adjust, adjacent. Mirrors which can be encountered only by utilizing more ground space, which increase cost. Very high temperatures are not produced as compared to a parabolic probe or a solar tower, and therefore the efficiency is less. Ito daw yung ginagamit ang mga flat mirror na mas mura and ang isang disadvantage Sa isang sa disenyong ito ay ang shading effect na mga katabing salamin na makikita lamang sa pamamagitan ng paggamit ng group space which increase cost. This consists of set of flat mirrors combined to the form of large parabolic dishes that is attached to a motor sensor which tracks the movement of the sun in dual axis. The collected energy from the sun is being concentrated to the PCU located at the focal point of the dish. The PCU consists mainly of the thermal receiver, sun steering engine. The thermal receiver, which is a heat exchanger, transfers its heat to the steering engine, causing it to reciprocate. This reciprocating movement causes the rotation of an electric generator. Ito daw yung this consists of set of flat mirror na pinagsama upang bumuo ng isang malaking parabolic dish na nakakabit sa isang motor sensor which tracks the movement of the sun in dual axis. Parabolic dish. These dishes can concentrate sunlight much better than parabolic through and the and the fluid run through them can reach temperatures upwards of 750 degrees Celsius because of the limitation of size and the small quantity of fluid. Parabolic dish collectors are sustainable for small-scale power generation. These dishes can concentrate ng sikat ng araw ng mas mahusay kaysa sa parabolic through. Pataas pataas ng 750 degrees Celsius. Steering engine. The Stirling engines can be hard to understand. Here are the key points. Every Stirling engine has a cylinder, which with one part hot and the other cold. The working gas inside the engine, which is often air, helium or hydrogen, is moved by mechanism from the hot side, the cold side. When the gas is on the hot side, it expands and pushes up on a piston. When it moves back to the cold side, it contracts. Ang mga steering engine ay maaaring mahirap maunawaan. Narito ang mga pangunahin. Ang bawat makina ng Stirling ay may sealed cylinder na ang isang bahagi ay mainit at ang isa naman ay malamig. This the example of steering engine. Displacer piston, power piston, heat source, cooling fins, flywheels, and the crankshaft. Largest solar thermal power station. This is the name, capacity, country, types, heat cost, and the area.